cumulative frequency and ogives are related to frequency tables. And if I have this frequency table that's shown here, where the first class has 2 things, second class has 3, so on and so on, the cumulative frequency for the first class would be 2. But then because we're talking about cumulative frequency, the next class would be 5. This is meaning that there are 5 items that are less than 65. The next class would be 17. There are 17 items less than 70. The next class would be 31. There are 31 items less than 75. And then 50. 50 items less than 80. 87 items less than 85. And finally, 109 items less than 90, which should account for all of our data that we have. And Ojive keeps track of this. So across the bottom here, this is going to be the weight, so I need to go up to 90, and the Ojive is going to start at 0. So 90, that's a little less than half, so I'm going to mark that as 40. So I know my scale isn't perfect here, but each mark would represent 10. And then I'm going to need to go up to 109 at the top value. So I'll call this 50, 25, 75, 100 would be a little less, and you could make a nicer scale using a ruler here. But now I'm going to plot for this at 60, it's going to be at 2. So not very high. And then 65, we're at 5. And then 17, and I'm just making a crude sketch of what this ogive would be. Hopefully you would make this on graph paper and do a much nicer job than I'm doing. So for 75, there's 31 items less than that. For 80, there's 50 items. $85, we're at 87, and then 90, we're up at 109. And what we're going to do now is we're going to connect these dots. So there is the ogive representing this data. Now what we can also do is we can add to the right hand side a percentage scale. Up at the top would be 100%. Halfway would be 50%. That would be, in other words, the 50th percentile. The 25th percentile, or Q1, and then this would be the 75th percentile, and we could break it down further, but what I can do is I can kind of extend this 50th percentile over and I can see what would be halfway on this ogive to give me my median, what would be the middle value. So I can just take the 109 and cut that in half, take 50% of it. And so I'd have 54.5 as the median. And I could do the same thing to figure out what's the 25th percentile. I can take 25% of 109, or the 75th percentile, or if I want the 64th percentile, I could say what percent of the data is between 0 and whatever percent that I have. So I just have to take 109 times a percentage. That gives me my percentile value. So the quartiles are the same as the 25th percentile and the 75th percentile, and for that matter the 50th percentile. The lower quartile is Q1, 25% of our data is below it. The middle quartile, Q2, is the median, 50% of our data is below that. And the upper quartile is called Q3, that's the median of the top half of our data. Then we also talk about the interquartile range, or the IQR, and that's found by taking Q3 minus Q1. The 5-number summary are the 5 numbers that are associated with the minimum, the maximum, and then Q1, Q3 that should say, and the median. So I want to make a box plot for this. First thing that we have to do is we have to list this data in order so that we can find the quartiles. And I find it useful to cross things off as I write it down. 3, 3, 3, 3 threes. 4, 4, 2 fours. 4 fives. And then I have a 6, 2 sevens, an 8, and a 9. And I'm just going to go back and double check that I have the right number of data values right now, and just count the number of things in my list. And I've got all my numbers accounted for. So now I need to look at finding the median for my 5-number summary. So I'll cross items off each end of the list. And the median value is 5. To find Q1, I'm going to look at all those values. So now I'm going to cross off in this list and find the median of the lower half. Q1 would be 3. And then I'm going to do the same thing with the upper half of data. Q3 is 6.5. And then I also have, as part of my 5-number summary, the minimum is 1 and the maximum is 9. To make my box plot, I want to create a scale. And above each one of the numbers in my 5-number summary, I'm going to put a vertical mark. So 1, 3, 5, 6.5, and 9. And then around the 3 quartiles, I'm going to make my box, and then from the ends of the box out to my maximum and minimum, those are my whiskers. So the box is showing us where the middle 50% of the data is, and each whisker represents 25% of the data. When you're doing these, you need to have a scale. You also need to say what the 5-number summary is so we know what values are going with this graph. The standard deviation is found based off of something called variance, and it's measuring the standard distance away from the mean that something is. And we talk about x minus x bar squared so that those distances are all positive, but the problem there is the units end up being, for instance, if we're dealing with data in kilograms, the units of variance are kilograms squared. So we talk about the standard deviation instead, which is just the square root of this variance. And sometimes you'll see it written a little simpler like this without the subscripts. But it's just saying take all the x values, all the data values, and subtract the mean, square it, then add all those up, divide by n, and then take the square root. So I want to find the standard deviation of these numbers. Based on that formula, we need to find x minus x bar. So the first thing that I need to find is the mean. So we add these numbers up, and then we can divide by how many there are. So these add up to be 60. So the mean is going to be 60 divided by 6, which is 10. So I'm going to take each one of these data values and subtract 10 from it. So negative 5, 7, 5, negative 7, negative 1, and 2. And then in the next column that I can add to this data, I'm going to do x minus x bar, that previous column, and I'm going to square it. So now I'm looking at 25, 49, 25, 49, 1, and 4, and then I'm going to add all these numbers up, which ends up being 150. So now the standard deviation is going to be the square root of 150 divided by 6, which is 5. Standard deviation is measuring how spread out things are in comparison to the mean. So the bigger the standard deviation is, the more spread out our data is going to be.